It's in the battery in your alarm clock. It's in your toothpaste. It's in your cup of instant coffee. And in your shoe polish. It's in your carpet. And your vehicle spark plugs and in gasoline. It's even being bred to grow on Mars. Simply put, when it comes to crops, corn is the king. North Americans eat an average of 45 pounds of corn every year. That may seem like a staggering statistic, but the majority of that corn doesn't come on the cob or in a can. What we're digesting for the most part are products made from corn. Of the some 10,000 items found in a regular supermarket, it's difficult to find one that hasn't been touched by corn in some form or another. To understand what makes corn so versatile, you have to get inside the kernel itself.
When you take a kernel of corn, you want to process it into products. What you want to really try and capture is the starch. The corn kernel itself, it has three components. There's the skin of the pericarp. There's the embryo, which is the small part of the embryonic plant. It's the germ. And then the rest of that is cornstarch. The starch is a store of energy for the embryonic plant to grow the next year.
Starch is corn's most valuable commodity. It makes up about 68% of the kernel, and once you've tapped into it, you're on your way to manufacturing everything from the obvious cornstarch to adhesives for cardboard boxes and sugar for your favorite candy. The process is called wet milling. After the corn kernels arrive, they're soaked in warm water until they swell to 30% moisture, making them big enough to grind down. This process also softens the fiber and loosens the starch. The corn is then run through a mill that frees the germ and loosens the fiber. Starch and gluten are then separated from the germ. The pasty yellow gluten is squeezed out in this centrifugal machine and is sent off to make gluten feed for animals. The starch is washed and can remain as powdery cornstarch, which is used as a food thickener, or it can be converted to dextrose or liquid glucose, highly versatile products on their own.
You can take that dextrose and make it into adhesives or make it into starch for coatings. You can dry it down and make it into starch for baking and cooking. That's corn starch. If you further refine that down, you can get into a glucose stream, and from that you can make any kind of high fructose corn syrup or sweeteners. In fact, in North America, other than I think it's 2 diet pops, everything else, all the sugar in that comes from corn glucose. So the wet milling process takes cornstarch, converts it into dextrose, converts it into glucose, converts it into these sugar additives or some other bioorganic chemicals if we keep going, and if you keep on going down through the processing, you end up with ethanol.
Ethanol, arguably corn's most important byproduct. You see, our planet is slowly running out of fossil fuels like oil. And without a replacement, one day we may all be stranded at the side of the road. But ethanol may be our savior. You see, ethanol contains oxygen, which is needed for combustion, so it burns more cleanly and more efficiently than gasoline does. And of course, it's also a renewable resource. Today, cars can already run on about 10% ethanol, but manufacturers are working on boosting that up to about 85%. So you see, one day, the benefits of corn may not be limited to our dinner plate. The benefits will also extend right into our gas tank. New ethanol plants are popping up all over the place. This plant happens to be in Chatham, Ontario. When you manufacture ethanol from corn, guess what? You get even more bonus products from the crop. It starts with fermenting the kernels in giant vats.
In fermenting, you're taking those sugars and you're converting them into alcohol. You capture the alcohol, distill water out, and you end up with fuel-grade ethanol. The other byproduct in the fermentation process is you give off carbon dioxide. So you capture the carbon dioxide and you use that in the beverage industry. So now you've got ethanol, you have carbon dioxide, and what's left is the mash that you started with. And that's distilled dried greens and has all the protein still in it, and it becomes a feed additive or a feed base. So from corn, you get three products in the ethanol process: 1/3 ethanol, 1/3 distilled dried grain, and 1/3 carbon dioxide.
All this talk about corn and not a word about munching down on a sweet, buttery cob. Well, the fact is that with corn busy producing thousands of byproducts for industry and food manufacturers, not to mention how much goes directly to animal feed, only about 5% of the grain planted is actually for direct human consumption. When Europeans arrived in Central America in the 16th century, they noted that native Indians always added a pinch of ash to the corn pot. Somehow, these natives knew that ash softens the skins of the kernels, making them easier to digest. The lime contained in the ash also releases a vitamin called niacin from the corn, allowing humans to benefit from it. The native Indians' phenomenal understanding of the intricacies of maize is a testament to their relationship with the grain.
Today, our relationship with corn can sometimes get a little wacky.
Yes, these folks are actually jamming as many cobs as they possibly can into their partners' overalls. At the end of the race, participants and spectators get to take as many cobs as they can carry home for dinner. In fact, this place goes corn crazy every August. The population of this 7,500 resident town doubles on Corn Festival weekend. It has become legendary. The Corn Fest in Taber, Alberta. Taber, you should know, is the corn capital of Canada. Why? Because in this little corner of southern Alberta, conditions are magical. You have just the right temperature during the day and nice cool nights, and that makes for perfect corn. You have the best blend of minerals in the soil. I've been told it makes for the best tasting corn in the country. I've been told right. Just the right blend of sucrose and glucose and starch. Someone who definitely agrees is Brian Hunt. He lives in the area and works in Taber as a crop rotation specialist.
Taber sweet corn is considered to be the best in the country. We feel that it is because of the climate. The sugar production in corn, particularly sweet corn, is intensified when the corn is under just a little bit of stress. And we feel that the cool nights that we experience because of our proximity to the mountains actually cools the plant off enough that it transports sugar into the cobs and into the kernels on a regular basis each evening. And that gives you a sweeter corn.
Believe it or not, that delicious sweet corn is a genetic mutation. Its sweetness comes from a recessive gene, which prevents the sugar from fully converting into starch. And you could also say it's the veal of vegetables.
What we're eating when we're eating sweet corn is an immature corn cob. And what we want to maintain in an immature corn cob is the moisture content and the sweetness. And the sweetness has been bred over a number of years.
You have to be pretty swift to make the most of that sweet corn taste. Within 6 hours of being harvested, corn will lose as much as 40% of its sugar if it's kept at room temperature. The cob is using its own sugar to stay alive and ends up wrinkled and shriveled pretty quickly. When we do eat it, corn is a great source of fiber and, unfortunately, not much else.
It's almost pure starch with very little protein, if just a trace, and a few nutrients like B complex, except for niacin and fiber. Other than that, it's not the most nutrient-dense food, but it's great as a snack, and it's quite delicious.
One corn component, however, is receiving attention from researchers. It seems that lutein may play a role in reducing the risk of eye problems and even heart disease. But corn is not a staple. To get the real benefits of corn, it must be eaten in conjunction with other foods. This is something the native Indians have always known. In fact, corn is part of a trio known as the Three Sisters. Even in ancient times, it was planted and eaten with beans and squash. The three combined provide a staple food, which is still common in the Central American diet. As long as there has been corn, humans have had to compete with nature for it. This explains the native Indians' method of farming. The Three Sisters were planted together in mounds of soil. The corn grew straight and tall, while the beans wrapped themselves around the cornstalk, and the third sister, Squash, spread herself over the land between the soil mounds. This really cut down on the weeds. And a fish tossed into each mound to decompose was the Indian way of fertilizing the soil. Once you've got the right moisture content in the soil, a good amount of organic matter, and the right temperature, you may think you can just sit back and wait for the sweet cobs to arrive. Well, think again. There are other creatures on Earth that love corn too, and no doubt they'll get to it first. Left to their own devices, parasites and fungi can cause huge problems. Just look at the state of these cobs. They have been attacked by a fungus known as Fusarium graminearum. This fungus causes major crop damage to corn destined for animal feed. If it gets into the feed itself, the fungus can release toxins that make the animals sick. There is no pesticide that can combat this problem. But here, at the University of Guelph, researchers are hoping that a particular rice gene, which naturally repels the Fusarium fungus, will do the same thing once it's been genetically modified into the corn crop. It may take 10 years for something like this to ever make it to market, assuming that it's successful. Here, at Agriculture Canada's experimental farm in Ottawa, scientists are also breeding corn that can withstand Canada's colder climate and resist disease. It's a lengthy process, but starts with the breeding basics.
Corn plants have both the male and female part of their flowers. The ear is the female part, the tassel is the male part. Each of these silks belong to one kernel. Pollen from the male part of the flower falls down onto the silks, and then a pollen grain will land on the silk, grow down the silk, and fertilize one seed or one grain of corn. When we want to do these pollinations ourselves, we put a white bag over the ear before the silks are exposed. Then when the pollen starts to shed and we can see that the silks are growing under the bag, we put a bag over the tassel, we shake the pollen off of the tassel, take that bag and replace it over the silks, and it'll make the pollen from this plant fertilize only this ear.
The paper bag method may be low-tech, but it certainly controls the pollination procedure during breeding. After several generations of doing this, you'll get an inbred variety of corn which can be crossed with another inbred to create a hybrid. The hope is that the best traits from each inbred variety make for a strong hybrid.
For example, you could have one inbred that has good disease resistance, but perhaps doesn't yield as high, and another inbred that has poor disease resistance but yields high. And sometimes, if you get the right combination of those two inbreds, you'll have a hybrid that has pretty good disease resistance and pretty good yield.
The varieties of corn one can create are limited only by the human imagination.
Geneticist Walton Gallinat is proof of that. If corn is king, then Gallinat is the king of corn. He has devoted his entire life to maize. And if he could be corn, he would.
A time will come, perhaps hundreds of years from now, when we build colonies on Mars, and no one is working with corn for Mars. So I decided I'd better breed some corn that would resist ultraviolet light, be able to withstand arid conditions, and provide both food to eat and oxygen to breathe, so that these people could survive if they ever get there.
Gallinat is also famous for generating corn art. He has illustrated thousands of pictures. He has bred the world's largest corn, square cobs of corn, and now he's the only scientist in the world breeding corn for another planet. He says corn is the perfect choice because it produces more oxygen through photosynthesis than wheat, barley, or any other cereal.
When we eat a plant, we give back carbon dioxide, which the photosynthetic plants convert to food on the one hand and give off oxygen for us to breathe. And once corn is grown on Mars, it will continue to do the same as it does here on Earth. It will allow the building of a human society there and a breathable atmosphere.
Back here on Earth, one of the most popular ways of eating corn is also the most ancient: popped. Archaeologists continually hunt for evidence of corn's ancestor, a wild grass. In 1948, a remarkable discovery was made in the Bat Cave of New Mexico. Scientists discovered ancient remnants of corn, 700 cobs in all, each no longer than a fingernail. They were determined to be 5,600 years old. Even more astonishing was the discovery of popcorn, each kernel enclosed in its own husk. Scientists dropped a few of the unpopped kernels into oil, and lo and behold, the ancient corn still popped. It turns out that the world's oldest snack food is also the oldest type of corn in the world. No doubt, the accidental explosion of a kernel in an open fire introduced Mexicans to the fluffy food thousands of years ago. And when we talk about popcorn, we really are referring to a different type of corn altogether. Its characteristics are unique in the corn world.
Popcorn tends to be a much smaller seeded corn than other corn. They have been selected for the ability of the starchy endosperm upon heating to expand rapidly, and that causes the kernel to basically erupt and make your puffy popcorn. You can pop most types of corn. Regular grain corn, you can pop it. It just doesn't have the texture and the flavor that current day popcorn has had bred into it.
True, all kinds of corn will pop to a certain degree, but the kernels won't turn inside out and puff up as much. Popcorn needs a different type of starch than other corns.
It has a genetic propensity to have very hard starch, such that when you heat it up, the water vapor inside the kernel can't escape. So it heats up, and explodes. So popcorn pops because it's a very hard endosperm.
The other important factor besides starch is the moisture content. If it's not right, it won't pop. The water content within the starch needs to be about 14% for a perfect pop. During cooking, the pressure from heat turns the water into steam, and the kernel explodes. But how does it form a white, solid outer layer? Well, the starch doesn't disappear in the explosion. it actually expands into thin bubbles which merge together and solidify into a three-dimensional network. Think of it as being like a miniature loaf of bread rising in a very fast motion. And it goes one step further. It turns inside out.
If bread did this, the crust would be on the inside.
In the 1990s, theater popcorn came under scrutiny because of its fat content. Analysis showed that a large bag of popcorn contained about 50 grams of saturated fat. That's more than 3 times the recommended daily intake. Now, it wasn't the fault of the corn. Turns out that most theaters were popping the corn in coconut oil, and that contains a lot of saturates. But as with most foods, if you want to make popcorn healthier, well, just make it at home.
Popcorn can be quite a healthy snack if it's air popped with a little bit of pure butter put on top, or a healthier oil like flaxseed oil, for example, and some spices and other healthier ingredients. Microwavable popcorn and movie popcorn, however, are high in hydrogenated fats, lots of preservatives, other unnatural chemicals. They're high in saturated fats and extremely high in sodium, and are generally a very poor contribution to the human diet.
And there's the paradox. As humans, we can choose to live without corn as a vegetable in our diet quite easily. But as a human race, it's impossible to imagine our world without it. Our lives simply wouldn't be the same. There is no substitute for the versatility of corn. It's in virtually everything we touch in some form or another. And in years to come, as we seek alternative forms of energy, it seems likely that farmers will have to make even more room for corn in the fields of the future.